Hello students, I am ready with my next video, second order derivative in PUC second year mathematics. Topic is second order derivatives. We have already seen exercise 5.7, exercise 5.7. 8 questions have already been explained. This is the 9th question now. We are in 9th question. Here is the question. Question number 9. Log of log x. Log of log x. We have log. Then in place of x, we have log x again. We all know the derivative of log x is 1 by x, right? Derivative of log x is 1 by x. We have log here, just like this. We have log here, but in place of x, we have again log x here. So it's a composite function. So we have to use chain rule, and we have to differentiate, right? So let's say the given function is y log of log x. Y is equal to log of log x. You can take f of x is equal to also differentiate with respect to x. So this is same as log, this is x, log x, log, this is all x, right? So differentiation will be, first order derivative will be, if we differentiate with respect to x, divided by dx will be equal to 1 by, we must write x, but here in place of x we have log x, so this all log x will come, right? Log, this is x, so 1 by x, so this is x. Right? Okay. Into, then we have to again differentiate log x with respect to x, right? Because it's a chain rule. We did the differentiation of this log, but this log is remaining again, right? So it will be dy by dx is equal to 1 by log x into differentiation of log x is 1 by x. In my previous videos, I did not write this step. I was just writing this step directly, right? You can do this also. For your better understanding, I have done this. So 1 by log x into 1 by x is, this is the first order derivative. But we have to find second order derivative. So this will become dy by dx is equal to 1 by x log x. This is the first order derivative. We have to differentiate again. We have to find second order derivative. Once more we have to differentiate, right? This is in the form of 1 by k by x raised to n. If you remember, k by x raised to n, k divided by x raised to n. Differentiation of constant divided by x raised to n. Differentiation of constant divided by x raised to n. Constant 1 x. This is all x. Raised to n to the power, here it is 1. We do not have any power, means it is 1, right? So what happens here? We all know that we change the sign, then this power gets multiplied to this numerator n into k divided by x raised to, we add 1 in power, right? So we have to do the same thing. So d square y by dx square, we again differentiate here, So that will become, first change the sign, because it's positive, it becomes negative. If it was negative, then we will make it positive, right? And then these two constants will multiply. 1 into 1 is 1 divided by this x log x to the power, add 1, that will become 2, right? Now, but we cannot leave it like this. Because here it is x, the base is x here. So we have to differentiate this x, but the differentiation of x is 1, so we can leave it, no problem. But here in place of x, we have x log x, so we have to differentiate this also. And this is in uv form, u into v. So it will become first derivative, first function as it is, differentiation of second, that is 1 by x. First x as it is, differentiation of log x is 1 by x, plus second function log x as it is, into differentiation of first, differentiation of x is 1. We did this here, but we are again differentiating this, because it's not just x, it's x log x. right? Now this will be, here we cancel x, so it will become d square y by dx square is equal to minus 1 divided by x log x whole square into, this will be 1 plus log x. This is the final answer. Or you can write 1 plus log x divided by x log x whole square. That is also correct. That is minus 1 plus log x divided by x log x whole square. This is the final answer. This is question number 9. Let's see question number 10. Question number 10 is sine of log x. We have one more question here. Question number 10. Question number 10 is sine of log x. Let's say y is equal to sine of log x. Y is equal to sine of log x. This is same as sine x, right? But in place of x we have log x. So in case of sine x, what do we do? Differentiation of sine x is cos x. Into we must differentiate x also, that will be 1, so no need to do, right? But here we have to differentiate. So differentiate with respect to x. Differentiate with respect to x, it will become y1 is equal to sine of log x will become cos of log x. Differentiation of sine x is cos x into differentiation of log x is 1 by x, right? So we have y1 cos of log x divided by x. This is first order derivative. We have to differentiate this again once more because we have to find second order derivative. So differentiate again with respect to x. So that becomes y2 is equal to, this is u by v. You have to use u by v rule because we have a function here in numerator, we have a function in denominator also. So you have to use u by v. U by v rule is v as it is, denominator as it is, differentiation of u. Differentiation of cos of log x will be minus sine of log x. Cos x is minus sine x into, you have to differentiate log x also, that is 1 by x. Denominator as it is, differentiation of numerator, minus numerator as it is, cos of log x as it is, differentiation of denominator, differentiation of x is 1. We have x in denominator, so its differentiation is 1. Whole divided by denominator square. This is the formula, right? U by v formula, u by v, differentiation of u by v with respect to x, v into du by dx minus u into dv by dx divided by v square. This is the formula, right? So this x will get cancelled here. So y2 will be equal to, this is minus sine of log x minus cos of log x divided by x square. This is the final answer. You can just take minus common here, that is the more simplification we can do, or you can leave it like this, it's okay. Second order derivative is over. Question number 9 and question number 10. Let's see question number 11 now. Question number 11, we are ready with question number 11. If y is equal to 5 cos x minus 3 sin x, prove that d2y by dx square or d square y by dx square plus y is equal to 0. We have to get this equation as answer. This is the given equation. We have to get this as the answer. So what is the given equation? Y is equal to 5 cos x minus 3 sin x. From what we have to prove, it is clear that we have to find second order derivative, right? Then only we can get this. Okay. So first find first order derivative, that is differentiate with respect to x. So dy by dx will be equal to differentiation of y, we have this. Differentiate this, 5 constant as it is. Differentiation of cos x is minus sin x, right? Minus 3 constant as it is. Differentiation of sin x is cos x. So we got this dy by dx is equal to minus 5 sin x minus 3 cos x. We got this. Now again differentiate with respect to x. Again differentiate with respect to x. Again differentiate. So that will become d square y by dx square is equal to minus 5 as it is, minus 5 constant as it is. Differentiation of sin x is cos x minus 3 constant as it is. Differentiation of cos x is minus sin x, right? So we get d square y by dx square is equal to minus 5 cos x. This becomes plus 3 sin x, right? Now d square y by dx square is equal to, take minus common in these two. When we take minus as common sign, then it becomes 5 cos x, negative will become positive, and positive term will become negative because of taking minus sign. It becomes minus 3 sin x, right? Now we have d square y by dx square is equal to minus as it is, this minus as it is. If you observe carefully, this is the given equation. This is the given equation. See, 5 cos x minus 3 sin x. 5 cos x minus 3 sin x is nothing but y. Y is equal to this. So we have the same here. This same is here. So can we replace this by y? Yes, it is given. Or you can do this. Use this as equation number 1. Make it equation number 1. And write minus y. Why? Because from equation 1. From 1. Then take this minus y here. Take this minus y here. It becomes d square y by dx square. Take this minus y to LHS. It becomes plus y is equal to what is left on RHS, that is 0. We got the equation which we had to get. This one, d square y by dx square plus y is equal to 0. What did we do here? We did not just differentiate, we differentiated twice, and then we used the given equation also to get what is required. Question number 12. We are ready with next question. Question number 12 is, if y is equal to cos inverse x, y is equal to cos inverse x, find d square y by dx square in terms of y alone. We have to find second order derivative. We have to find second order derivative d square y by dx square, but there is a condition. What is that? That d square y by dx square must have only y variable. In terms of y only, x must not be there. When we get this second order derivative, it must be purely in y, not in x. X must not be there. This is the condition, right? So what is the given equation? Y is equal to cos inverse x. Clearly, if we differentiate it directly, if we write the derivative of this, this will be dy by dx is equal to 1 minus 1 by root 1 minus x square. This is the differentiation of cos inverse x. We know cos inverse x is minus 1 by root 1 minus x square. The problem is that if we continue differentiating this, then we will definitely, here x is coming in the next second order derivative, again we have to differentiate this, then inside we will differentiate, then x will come again. We will not get rid of x, we will have x. If we continue this way, we will have x in second order derivative, but the question says x must not be there. Second order derivative must be free from x. It must have only y. It must be in terms of y alone. So what should we do now? Now we have to get rid of x. We must make x disappear. What can we do? If the differentiation of x becomes 1, if differentiation of x, if we differentiate, if there is only x and x becomes 1, then we will get rid of x, right? So we can do one thing, but when x is attached to cos inverse, we cannot do that. So if we make it alone, if we make x alone, not attached to cos inverse, then it will become 1 in first order derivative, and in second order derivative there will be no x. So for that, take cos inverse here. We all know from inverse trigonometry, that if x is equal to cos theta, then theta is equal to cos inverse x. Right? You can take this here. You can transfer just cos inverse here. So it becomes, when you transfer it becomes cos y is equal to x. Inverse will be gone because of taking it here, right? From inverse trigonometry. So from inverse trigonometry we know that cos y will be equal to x. Now differentiate with respect to x. Differentiate with respect to x. So what will happen? Differentiation of cos y will be minus sin y into, we cannot just leave it because we have y here. If it was cos x, if it is cos x, then we write differentiation as minus sin x, and we do not differentiate x because it becomes 1. But here it is not x, it is y. So cos y, and we are differentiating with respect to x, not with respect to y. If we were differentiating with respect to y, then cos y will become minus sin y, and no need to differentiate y because y with respect to y will become 1. But we are differentiating with respect to x. So cos y becomes minus sin y into this y. Differentiation of y will be dy by dx. Differentiation of y dy by dx is equal to, this is the differentiation of this. Cos y is minus sin y into dy by dx with respect to x, and x with respect to x is 1. We know that differentiation of x with respect to x is 1. So we got this, right? Now, so now dy by dx will be equal to minus 1 by sin y, taking sin here, right? So this is first order derivative. Now for second order derivative, differentiate again differentiate with respect to x. Again differentiate. So it becomes d square y by dx square is equal to, this is in the form of, again it is in the form of k x raised to n, k divided by x raised to n, k divided by x raised to n. We change the sign and we have to do that one. Here it is negative, so it will become positive. Then the power of this is 1 here. It will multiply with this one. 1 1 is a 1. And then sin y power will become 2, 1 plus 1, n plus 1, right? 1 plus 1 into, we have to now differentiate sin y. Sin y differentiation is cos y into dy by dx alone. dy by dx again, right? Sin y differentiation cos y, then again differentiation of y. That is dy by dx. Now, this becomes d square y by dx square is equal to cos y divided by sin y whole square into this cos y into 1 is cos y divided by sin y dy by dx. What is dy by dx? dy by dx is minus 1 by sin y. So can we replace dy by dx by minus 1 by sin y? Yes, from here. dy by dx is minus 1 by sin y. Right? Okay. Then, so this becomes d square y by dx square is equal to minus cos y into 1 is cos y divided by sin y square into sin y cube or sin cube y. Sin cube y or sin y whole cube. This is the answer. Or you can simplify like this. You can just take d square y by dx square will be equal to, some more simplification is cos y divided by, take one sign from here, cos by sin is cot, cos by sin is cot, we are taking one sign from here, cos by sin, there are 3 sign here, 3 sign are there, sin cube is there, right? So one cos, one sin, cos by sin will become cot y into, then here sin square is left, that sin square if I bring it up, sin when we from numerator it goes in denominator, from denominator it goes numerator, it changes to its reciprocal. The reciprocal of sin is cosec, so it becomes cosec square y minus cot y into cosec square y. This you can simplify more, right? Or you can leave it like this. This is the answer. I hope you all understood these problems. Some more problems are there in this exercise. We'll do those problems tomorrow. And these problems are also very important. Practice each problem many times so that you will be good at solving not just these questions but also other questions. Thank you for watching.